Review of area. So here's a collection of area formulae. Obviously there are more formulae than these, different shapes than these, combinations of these formulae, different ways to find the area of a triangle, etc. But here's a selection of quite commonly known ones. We haven't obviously included the area for a rectangle. We expect you know that that's length times width or base times height, or however you choose to define the lengths. So obviously, you know, even for the area of a triangle, half times base times height is the same as base times height divided by 2, and you might use different versions depending on the sorts of numbers that you're dealing with. For example, if the base length is a fraction, base times height all over 2 is a more complicated expression to write compared with half times base times height. So you want to be flexible about how you understand these formulas. So let's just work through a series of examples, mostly compound shapes, meaning it's a mixture of different shapes. So here we have a rectangle plus a semicircle. So a couple of things we want to work on getting right. You're setting out. So obviously you could find the area of the rectangle at one side of your page and the area of the semicircle on another side of the page and put them together to find a total area. And if you're going to do that in those different steps, be clear about what you're doing. Signpost things, really clear notation. Perhaps call it A1 and A2 and be clear about what's happening. I personally prefer to set everything up right at the beginning as a total area. You're doing all the same calculations and it's much neater and clearer and easier to follow personally. Also, it's going to extend into problems where it's not the area that we're trying to find, it's one of the other unknown quantities. Being able to set up just one expression right from the beginning has more useful applications going forward. Okay, so if we're finding the area of this shape, so immediately I'm thinking, well, area, I've got that rectangle, plus I've also got that semicircle. Obviously you don't need this step, I'm just trying to be clear about what we're doing. The rectangle has dimensions 8 by 10. The important information in the semicircle is that the radius is 4 in this case. So a rectangle, the area of that is just 8 times 10. Plus we also have half of a circle, so that's half times pi r squared, so half times pi times 4 squared. Now just notation things, we only omit the multiplication symbol if it's at the number is at the beginning or is before the pronumeral. So if we're writing 4 pi, it's fine to write 4 pi rather than 4 times pi. If however I'm writing pi times 4, I wouldn't write pi 4. I'd write pi times 4. So again, just some notational things. Also, if the radius there was a fraction, I would need to make sure I have brackets around that because I'm going to square the whole fraction. So watching for things like that as well. So 8 times 10 is 80, plus we have half times 16 pi. Now I want you to avoid the temptation to go straight to a calculator. Here the question specifies first giving our answer exactly and then to 2 decimal places. Again, down the track we're going to be working exactly all the time and we would be leaving our answer as 80 plus 8 pi. That's the exact area of this shape. This question here does ask me for a decimal approximation and I've worked that out previously with my calculator and it is 105.13. But both of these answers, these last 2 lines, are the final answer to the question. In fact, the second last line is the more accurate final answer to the question. So we want to think about units here, where area, so it's units squared and it's centimetres. So 80 plus 8 pi centimetres squared is the exact answer. 105.13 centimetres squared is the approximate answer to 2 decimal places. The other thing to be clear about is when you're doing calculations involving measurement, don't include units within the calculation. So don't write 8 centimetres times 10 centimetres plus half times pi times 4 centimetres squared. All those letters within the calculation get confused with algebraic terms and things. Just include units on your final answer at the end. Okay, second example, a fairly simple compound shape made up of rectangles or rectangle in a square. So these kinds of shapes, there are a number of different ways that we could go about this. And for some people their instinct might be to break it in into 2 pieces this way. Some people might, let me just erase that line, some people might instead choose to break it into 2 pieces this way. If you really wanted to, you could choose to break it into 2 trapezia. by breaking it this way. So obviously people are going to have different preferences. My preference actually, or my instinct in this question, was to think about the total rectangle minus this area in here. So all sorts of different ways you can think about it, and often that idea of subtracting an area away from the total is a quicker way to do it. In this case, it's much of a muchness. So we're going to need to know this length here is 3 metres. To use my method, you might, depending on the way you broke it up, need to know that this length here is 2 metres, and you've got all the information that you need there. So if I think about the area as being the total rectangle, which is 5 by 4, minus this smaller rectangle, which is 2 by 3, then I can see that I'm going to have 5 times 4 minus 3 times 2, 20 minus 6, which gives me 14 metres squared. So lots of different ways to go about that problem, but sometimes look for the subtraction option rather than addition. There are examples where it is the easier option. Okay, third example. Here we have a sector. A sector is a wedge of a circle. Bounded by part of the circumference of a circle and 2 radii. So what we want to think about here is the fact that we know how to find the area of the total circle. So we've just got a piece of this total circle, and we need to know how big a piece we have, and that's where this angle here is important, because that's allowing us to work out what fraction of that total circle we have. We know that there are 360 degrees in total, and so we have 40 out of those 360 degrees. So that indicates to us the fraction of the pi that we have. So our area here, we've got 40 degrees out of a possible 360 degrees of, which is synonymous with multiplication, of the total area, so of pi times r squared. R in this case is 10. So 40 out of 360 is telling us that we have 1/9 of the total circle, which has an area of 100 pi. So our exact area for this sector is 100 pi over 9 centimetres squared. To give that as an approximate answer to 2 decimal places, again I've previously worked this one out, and it is 34.91 centimetres squared. So exact answer, 100 pi over 9 centimetres squared, or 100 over 9 pi is the same. Approximate answer to 2 decimal places, 34.91 centimetres squared. Okay, now final example, we have a fairly simple looking shape, a triangle and a square. Obviously those little lines indicate equal length. So we're going to need to break this shape up this way. The square is clearly easy, it's 3 by 3. The triangle, we know that the base length here is going to be 3 metres, but to work out area of a triangle we are also going to need to know the height. So we're going to need to think about that first. So obviously if we think about, let me just change pen colour for a moment so you can be clear what I'm talking about. If we think about this triangle in here, so that's a right angled triangle there. Its base length is half of 3, or 3 on 2 metres. Its hypotenuse is 3, and the height is unknown, and that's what we're trying to work out. Okay, so let's work out that height first. So we're going to need Pythagoras' theorem here. So we know that h squared plus, now be careful with the brackets there, we want all of 3 on 2 squared, equals 3 squared. Avoid the temptation to go to 1.5 squared. If you're working by hand, it's much easier to square a fraction than it is a decimal. 3 on 2 times 3 on 2 is 9 on 4. We're just squaring the numerator and squaring the denominator. So we have h squared plus 9 on 4 equals 9. So that is h squared equals, now I'm going to need a common denominator there, so 9 is 36 on 4, take away 9 on 4. And so that is 27 on 4. So h is the square root, and we only need to worry about the positive square root since h is a length, so it's going to be positive. Square root of 27 over 4. Now square root of 27, 9 goes into 27. 27 is 9 times 3. So that means simplifying that third, we're going to have 3 root 3 over square root of 4, which is 2. So the height of that triangle is 3 root 3 over 2 metres. Again, I'm going to avoid that temptation to go to my calculator at this point. I want to produce an exact value for the area, and it's going to involve a third. So we're going to stick with our exact calculations right till that last point, and then I'm also going to give an answer to 2 decimal places by entering it in my calculator at that point. If the question just asks for the answer to 2 decimal places, you can go to your calculator at this point and get an approximate value for h, but I would caution you, if you want your final answer to be correct to 2 decimal places, keep your value for h to 3 or 4 decimal places, so that then when you put it all together, you're not creating these compounded rounding errors, where you've rounded this number, you've then done other things to it, and then you've rounded it again. So you need to be very careful about working really accurately, which is why I just don't go to my calculator till the very last step. It's good for all our maths and algebra practice as well, our surds. Okay, so we've got our height of our triangle. So now we can think about the area. So the area of this shape is the square, the 3 by 3 square, plus the triangle, which has a base of 3 and a height, we've just worked out, to be 3 root 3 over 2. So my area is going to be 3 times 3 for the square, plus half times the base times the height. And again, this is an example where base times height over 2 would create an expression that's much more ugly to deal with than half times base times height. So 9 plus, now that's 3 over 1, so we've got 9 root 3, wrote 3 and said 9. Let's delete that. So we have 9 root 3 over 4, multiplying together those 3 fractions. And there's our exact answer. So the area here is 9 plus 9 root 3 over 4 metres squared. Now we could write that with a common denominator if we wanted, so we could have that as 36 plus 9 root 3 over all over 4 metres squared, no problem. They're exactly the same thing. And we could also go to our calculator here to get our answer to 2 decimal places, and it is 12.90. Now be careful with the rounding there. That required us to, I forget, it was, I think it was something like 12.998 or something like that. 898. And so obviously we needed to round up the second last digit, which then forced another round into the previous digit. So we wouldn't write just 12.9. That would be indicating that this answer is exactly 12.9. If we're giving the answer to 2 decimal places and there is something going on after this, which there is, we would leave it as 12.90. Units are metres squared. Right, so that's 4 examples on finding the area. Obviously finding areas is fairly straightforward, but it would be a good idea to really start to work on working exactly. Work on your setting out here so it's really clear and easy to see the sequence of how you've found things and how everything's come together. Try to write down one expression right from the beginning. Area equals this plus this plus this plus this, rather than lots of separate little bits of pieces all over the page that someone else needs to sort of make sense of. Right, so there is an exercise with some area review. Try and keep those things as a focus as you work through that exercise.